Hello, Mr. Martino here from your favorite teacher. Today we're going to continue our solutions to the 2017 June higher non-calculator paper. And the two questions we're going to look at today are question 16 and question 17. So let's go ahead. Question 16 says, n is an integer greater than 1, and we need to prove algebraically that n squared minus 2 minus n minus 2 squared is always an even number. Now the key here is an even number. So we need to understand, how do we prove something is an even number? To prove something is an even number, it must be divisible by 2. So what we need to do is we need to be able to factorize 2 out of our end result to prove it is an even number. If we can do that, then we've done the proof. So what I'm going to do is I'm going to start by expanding our expression. So it's going to be n squared minus 2 minus, and that thing in there squared is going to be n squared minus 4n plus 4. And let's now tidy this up. It's going to be n squared minus 2 minus n squared plus 4n minus 4. And if we collect all the terms that we can together, that becomes 4n minus 6. Because the n squareds cancel, so we're left with 4n minus 6. And we can say that 4n minus 6 is 2 into 2n minus 3. So therefore we can divide 4n minus 6 by 2. Hence, it is always an even number. Let's go on to the next question. Question 17 states, there are 9 counters in a bag, 7 are green, 2 are blue. Ria takes at random 2 of the counters from the bag. Work out the probability that she takes 1 of each color. So when we have this type of question, it usually means that we have to set up our probability tree. So I'm going to set up a tree that looks like this. This is going to be green, blue, green, blue, green, and blue. And we need to establish what the probabilities are. Everything is going to be over 9 to start. So it'll be 7 over 9 and 2 over 9. And if she takes 2 counters from the bag, it means that on the second pick, there are only 8 counters in the bag because she's already chosen a counter. So this is one of those questions that is not replaceable. So we now have here, if she takes a green counter, the second pick would be 6 counters out of 8. Blue would still be 2 counters out of 8. And here, if she took a blue counter, she would have 7 counters out of 8. And the probability here would be 1 out of 8. So we've established what our probabilities should be. And the question asks, work out the probability that Rhea takes one counter of each color. So the way in which we would get one counter of each color is if we start with a green and end with a blue, in other words, these two branches, or we start with a blue and then pick a green, or these two branches. So let's see what those calculations should be. The top one should be 7 over 9 multiplied by 2 over 8, which is 14 over 72. And the second one is 2 over 9 times 7 over 8, which again is 14 over 72. Since either one of these things can occur, we add the two probabilities and we get our total probability is 28 over 72. I hope this has been helpful. This is Mr. Martino for your favorite teacher.